Okay, so we're here, week 2.
Hello.
It's me and David, and we're doing week 2 of our ray tracing with or the Hidive Coding Club, and we're doing this ray tracing in a weekend and over a few weeks. So we made a branch last week, and I'm just going to merge this pull request. And yeah, today we'll be picking up where we left off. So I'm going to move over and pull down this repo. Alright, let's see. Make sure I have the changes. Do I?
What's happening there? Your local changes maybe overwritten.
Okay, so yeah, got the latest, and I'll git switch. I'll make a new branch. Week 2. Cool. So to refresh where we left off in ray tracing, I think we can do, is it zig build? Oh, zig build run, I think.
Oh, zig. Yeah, okay. Exactly, that's it.
So, and we are going to try using Z to edit this, which is oh, maybe I'll switch to a darker theme because it might frustrate people. Cool. Cool. Just move myself out of the way. Okay. So, oh, yes, I do want to
Oh.
I think I can call you on here. Whoa. David. Do I call you or do I just start?
I don't know.
Let's see.
I guess we could.
David accepts.
Okay, this is our call, I guess.
We're still learning how this works. But can you see my screen?
You are doing definitely something.
Yeah, okay, I see. And if you put your cursor and type something. Okay, cool.
You can also see me.
So David's orange and I'm here. And yeah, let's...
you called it ray tracing.
Oh, I'm in the build. So I want to move to main, right? This is where we were coding.
Oh, no, like the thing is, okay, so you just opened the folder like ray tracing.
Yes.
So it doesn't show the repo folder in a way, but it's
okay. I can move back.
That's fine, I think.
Okay. Yeah, I think we should be okay.
And now I just have to figure out split pane.
Save, build, run. Let's make sure that works. Whoops.
Oh, wait a second. I'm actually... Right, so I'm not touching anything on your computer in this window on my computer. Like anything that is opened in this window, in this call window, it's just files that I would be editing on your side.
I think so, yeah.
Which file? Build zig.
Yeah.
Build zig. You have it here. Okay, so undo everything. Okay. In that case, I don't have to do any like syncing with GitHub.
For some reason, it's building. Like if I go over here and do zig, build, run. Why am I getting these errors now? Is it what version of zig are we on?
Oh, let me see.
Maybe I'll try to. Oh, I think I ran into this before. I think it's just when you run zig build run, but you haven't changed anything, you'll get. Like I think when it does I'm curious. Like. So now if we go in here and I change something, we want to go to main. I don't know. Let's try. And also say like hi and save. Zig build run. Yeah, that works fine. Okay, so I just make changes between should be fine. Okay.
Maybe that's a bug. Like, it's still pretty evolving, right?
Right. Okay, so we...
I wonder why I cannot see the different file.
Which file?
Like the file browser. Or maybe I can just...
Or maybe I have to be the one to open them? I doubt that, though, right?
I'm in a build file. Ray tracing, week 2. Is this? Project panel. Oh, okay.
Cool.
That's fine. So now we are, like, you can also see me in the main file?
Yep.
Yeah, okay.
Okay, cool.
2D.
Yeah.
And then in that case...
We're just learning our tools.
Yeah. It does have a terminal, no?
Yeah, Command J pops it open, I think. But maybe you can't... It might be that you can't run the terminal because it's my machine.
Yeah. Okay, in that case, I guess you're going to be running it.
Yeah, but we can
I'm not going to be able to keep the changes in sync. Right? We would have to, like, commit after everything.
Well, we're going to write it together, the code, right?
Yeah.
Yeah. Okay. So,
all right.
Cool. And we are going to ray tracing open here. So where we left off last time was with reading this ppm image format. So there's a nice example of it here. And we're trying to reproduce this code block. So, right. Right, so we finally figured out last week, well, I guess, yeah, the homework that we were supposed to have was to figure out more of where to look up the print format stuff, but I did not do that, so...
yeah, I think I just checked, like, when I was doing it for myself, I just had it without any kind of format specifier.
Okay.
But I don't think this is inherently bad. Just like, you know that this is an integer, and so you just specify it as with this d.
Okay.
And so in this way, you just say the p3, the format, I guess, like a version of the format also, and the dimensions. So we are working with 256 and 256 at this moment, and it works. And then I guess the thing to see is, okay, maybe first we can write some data, very simple.
Okay, I'm noticing we're also missing this 255. So we have...
Oh, interesting.
Right,
that's
so
the maximum value for RGB.
Right, so here we want to also add... How are these separated? So it's...
a new line, isn't it?
So then we have a new line... Oh, where are we here? So it'll be new line 255. Okay.
So there's like, 256 values from 0 to 255. Okay, nice.
Okay, so, and that looks like the dimensions 3, 2, 255, and then this is where the data is coming from.
Yeah.
Okay.
So maybe we could try this as an example.
This one up here?
Yeah, just because I know that if we start writing the divisions, to figure out and filling and actually with some pattern the 256 by 256 field, I think this is we're gonna run into some kind of things that we're gonna have to solve. So maybe we can just copy this, the Wikipedia example, and see if we output it in a file that we can actually read it.
So now we want to do another standard out print, but with the data from this file. Is that what I'm thinking? Okay.
And you can just look it up on the ppm, like Wikipedia, because I think it's an image, right?
Yeah. Is it ppm or pm?
ppm file, I guess. Yeah, I think this is it.
Here.
Yeah.
Okay, so wait. Okay, so it's a 3 by 2. Max value is 255, and then you just feed in the RGB. This looks different though than the
one from
from here, right?
Yeah, because I think it's very ambiguous format, at least in my like I encountered some problems trying to see it in a preview program on Mac.
So what they do is for each, you just print out a new row with 3 characters. And it looks like here. Okay, so this is what we want to reproduce.
Yeah, okay. But this is, I guess, the alternative syntax that you can just like
3 on the same line.
I don't know.
RGB.
3. I guess it's
that
3.
would make sense. I guess it's like RGB. Or I guess I don't know. Okay. Okay, so if we like, my question is, should we I get here, maybe the easiest thing. I don't know how Zig does arrays, but if we like made each of these into just a string, right? Yeah, I'm curious how Zig does
arrays.
If you can do like a list of those.
Multi-dimensional arrays. Okay, so I guess you're looking. Oh, wonder. Interesting. So let me copy paste it. I guess this is how you do array.
You sent it?
Yeah, I just copy pasted it in here.
Okay.
But so it's for an unsigned int, like a car.
I think that would also. Maybe we can try.
It's possible that with strings, strings are sort of taken as a
UA
array of cars.
Expected U8 and a const. Okay.
Yeah, I think that's not gonna work.
Okay.
Just to, I guess we just.
I'll just do separate standout. Yeah.
But that's sort of why we're doing it, right? Because you might feel a bit dumb, but it's just a different paradigm that you have to learn.
Yeah. You could probably. Yeah, if you want to tackle one of these as I'm typing the other ones. We gotta get rid of this line.
Yeah.
Oh, and this too.
And then also, you didn't duplicate it.
Do we need a second argument? 2 arguments, so maybe the other one we need is an empty thing. Oops.
Yeah.
6 errors. What is expected tuple or struct and found?
Oh, it's like there's a dot before the curly braces.
Oh. It's just funny to learn the new syntax, you know, like.
Oh yeah.
Okay.
There we go.
Let's
something.
See. But we don't have new lines.
Yeah.
Hooray. Okay, so now if I zig build, I actually wonder, zig, maybe just run? Zig. Because I think I'm going to run into that issue where I get the compiler error again, but I can just try to image.ppm.
Okay, well, but that's interesting. Maybe that's something that we should solve.
I wonder what it is. So something's wrong with the format. So I wrote it here.
It is. It actually exists, and it's not 0. Okay. I wonder. There's a lot of spaces, right? Maybe if we get rid of the spaces.
Oh, like one space in between each? I see. Oh, like, yeah, like justified them or whatever.
Maybe that was just for the formatting.
It's still not working. Let's see. Okay, so if we go back to the ray tracing in a weekend, it's P. Let's compare.
What if you open it in, so preview just doesn't work?
Yeah, so if I open let's see. Is it portable bitmap for, okay, so it is recognizing it as a thing. And then I'm wondering.
Yeah, ppm, that's correct.
Image width, space. Are there any of these that are, does all look? I know what it is. I think we're supposed to do 3x2 and we're doing, it could be, is it
that's
3?
definitely,
2.
yeah.
Okay, so
there is something.
there we go. If we zoom in, okay,
nice.
We got it. Okay, cool.
I really thought it's going to be much difficult because I actually had a lot of problems getting it to show in preview.
Okay, cool. That is the funny quirk of these like file formats, right? It's like there's almost only one correct solution, and you can bang your head against the wall trying to get there sometimes. Okay, cool. So now we're going to learn for loops.
Yeah.
Right.
Well, let's look it up. So I think you have the documentation. I guess that's where you have everything, and I wonder if we have for loops. Okay. I'm looking at like siglang.org/documentation and /master. Yeah, and for, yeah.
Okay.
For basics. So,
Interesting. So you can have a collection, and you say for, then the collection, and then you almost have like a map. Like it's like it's a function that you like map over each of them. But I'm curious, like how something like is there such thing as like an iterator labeled for loop? Because we don't have like we have a sequence that we want to do in our case.
You need the indexes, you mean indices.
Yeah, and I guess that's kind of what this like labeled for looks like.
Yeah.
You have 1.6.
So that's also, I can also consult what I did before. And I essentially used this sort of interval
Okay, so if we do
notation. Yeah, so
link.
use essentially, I guess you need just something that is iterable, which this interval is, or how would you call it? So on the documentation, it is like this: iterate over consecutive integers. Use range syntax. That's what it's called.
Okay, so here we're constructing a range.
Range, yeah, exactly.
Maybe we could get a range or something. I can.
Yeah, I would assume that
Here we
there's
go.
going to be a range. Yeah.
At least it's maybe not the right section, but I see the range syntax.
Yeah,
so,
yeah. No,
okay.
That's what I was looking at also.
And we'll start at 0. Is that
start at 0, and then I guess this is non-inclusive because like it will finish with the last index that you will get is 255.
I see.
Unbounded range. Or no, okay, that's not the right word.
Okay, so we are iterating over image width and image height, and those are our i's and j's, which are, or no, we need j and then I.
Yeah.
Height. I guess you could reverse the two. Yeah.
Yeah.
This will be my j. This will be my I. Okay.
And then comes the fun part.
Right, so we want to create, I want to turn off Copilot actually because I don't hide inline complete. Okay, so we're going to do const r is equal to I. Okay, so it seems f64 divided by image width minus 1. Okay, so
did that what gave you the suggestion for the SF64?
I think I still have some Copilot on, so I can turn off.
No, I mean, I don't know.
I think it's
fine.
okay, yeah.
Like I had to figure out how to do this. Maybe that's not even the correct syntax actually.
The as stuff?
Yeah.
Interesting.
Maybe it could be like
0.0.
This is RGB,
and then we want to get,
I guess because you just have
int.
2 dimensions, so you have to set the third color channel for something.
So we want to get, what are they doing? Why are they doing 255.9? Oh, because it's for a floating point, and then we want to convert this.
I wonder, yeah, that's maybe interesting part, like 255. Why couldn't you just do 256.0? Because that also gives you a floating point.
I want to go up to, what is, so here do you remember what the data type is that we have for these? Like, how do I?
Oh, right.
I don't have like the hover ability, but it's okay. Maybe
Is that?
I think it might just be, the Z language server doesn't have that. Okay, so I'm going to run zig build. Let's just see if we can run this so far. I'm not printing anything yet, but I'm guessing we'll get an error. So it's saying expected after a colon after a statement.
Yeah, I just don't know if
that as doesn't work.
Yeah.
So if we go back to the docs and we look up float.
Yeah, I guess you want to think about casting. That's the thing now. There is a section on casting, and that is actually what I ended up using for.
This as.
Yeah,
keyword?
So it's like a
okay.
as
At
as.
Then the type. So we want like
type.
F32 maybe.
Oh yeah, that sounds good.
I wonder if we have to do it here too. Right?
Image width -1.
Because we need, like, I'm guessing for arithmetic, you have to have the same type on each side.
True.
And then we want it down here too, so Value, we want this to I32. I wonder, do they just have int? No. We could try it.
Yeah, I think you don't have to.
Because I thought there was something that was like the system integer that we ran into last time.
Primitive types, let's see.
Sig run, build, run. Okay. Undeclared identifier G. Oh.
Where?
Oh, J.
Yeah.
Okay, so no int.
No
int is not
ints,
a special thing, so let's just do I32.
Yeah.
I guess I should have known that. So apparently in my editor, and yours too, variables are white, and these identifiers seem to be rendered in green. So that makes
okay. So you could save it or direct.
Yeah. Sig. And now what's
What do
happening?
we have here? Unused. Oh, but
okay, so
okay.
we're cool. So there's an error because we're not actually using the stuff. So now we want to put these into IR, IG. Oh, whoops! No, that's not how you do it. It's D, right?
RGB.
But the
yeah,
syntax
true.
I think is like this, and then we had, and then you just do IR, IG, IB. Sig. Run.
Expected. Yeah. Okay. So, I, as it comes from is a U size. Is that U size? Okay. So this is unsigned pointer integer.
Right.
But it's interesting. So that's
we
what I had to do
can't cast
also.
that to a float.
Okay.
Expected type.
So here's what I did. If you like, I can provide this little help that I can, but I didn't get so far. So these little stumbles I can help from the beginning, but at some point we're gonna have to figure it on the spot. I just wrapped it to a different helper function. It's like add float from int, and
let's go to this.
Yeah.
So explicit casts are performed via built-in functions. Okay, so instead of doing,
I'm not sure what's the difference, to be honest.
Some explicit casts are no ops at runtime, some are not. So it seems like maybe there's a way that with the type helper, I'm trying to imagine. Okay, I think this is what it might be. So a U. So let's go back up to the @as. So I'm wondering where we learned this. Comp time T type expression. So this. Right, so you can use as when it's unambiguously safe to do so. So if you have a U8 and a U16, any U8 can be represented as a U16. You just reuse the same lower bits.
Okay.
And in this case, we're converting from a float and an int, which is an unsafe cast, or it like has it. There's some behavior where you have
losing some precision. Yeah,
you have exactly. So you're going to lose some information. So I guess in Zig, they prefer that you run one of these functions, and it says this float to int. So float
from int, I think.
Float from int.
Yeah.
Casting a floating point representation. The return type is inferred result type. To convert another way, int from float. Okay. So I guess that we'll swap these in. So we want float from int here. Float.
That was fine. Or wait a second, maybe.
That was where I got the error.
Wasn't okay.
Float from int.
Oh, maybe I did something actually.
G.
Yeah. Okay, this is much better. Yeah.
Oops. J. We want this to be the height.
Okay.
And then down here, I think we want the opposite one, right? So we want the int from float. From float.
Correct.
Whoops. Float from int must have a known result type. So maybe on the other side I need to...
So that's the other thing. Oh, okay.
Like maybe it has to get into the type system somehow. So maybe I need to say that this needs to be an F32. I wonder if the other... Let's try that. Float from int must have a known result type.
Oh yeah, so I think that's... It still doesn't know what the type should be for in here.
Okay.
Like for the whole expression, I can show you just like how I solved it exactly, but it doesn't really. Okay, so I
I see now.
You kind of convert this to int because you know. I guess this kind of gives you a better idea of what is expected in place of this, so you can do that.
Right. So I guess what it seems like to me is that you need, so this returns in any type, and then you need to have like something that says what you want that to be. So we could make that a float 64 or something like that.
Yeah.
And then it's interesting. It seemed like in yours that you don't actually need to, maybe division always is...
Yeah, that's the thing I'm kind of confused about, because it seems like you have to really explicitly say a lot of stuff, but the division is, I guess we just convert it to something that is divisible.
Right. It could be that it's whatever this type is. I don't know.
It just matches it, but there's
some
something
ambiguity.
I'm not understanding. Yeah. See, it seemed like the thing is, you just have to be unambiguous. And
so I'm curious now, Zig, will we get an error? Right, okay. So I was just testing. So here we also need to do, I'm doing a U size, which is what we could also use a different.
Sure.
Okay.
So it's something. File exists.
Okay.
There we go. So
cool.
With a little like help of stuff I kind of stumbled through and felt really, really stupid. Like at that time, like figuring out that I cannot even do a for loop and divide two numbers. We got through that pretty well. Okay,
so I'm going to, I'm going to make a commit now. So I'm going to just add this ppm, and the other thing that I didn't want was, there's another, I have a .ds store.
That's always there, I guess. Yeah, this git ignore is just copied from the Zig, but I guess you have to add the system-specific ignore rules.
Yeah, okay, so I'm going to just add, and let's say git commit, implement first ppm. Okay, cool. So we now have implemented this first step of the ray tracing, which is creating our first image. So yeah, walking through this code, I think I understand every line of this now. I'm still a little bit uncertain on like this, why this, like,
yeah,
I wish that, just because I know that my other editor does this, I'm just gonna do this quick. If we go to 6 down, really like it here. So it's interesting, it says this type is unknown. Or maybe I don't actually get that good of information. A comp time int. So I wonder.
Int, yeah. That's something that we still have to.
Yeah, so I'm not totally certain about the why you don't need to cast the lower bit here, but I think that's okay. We know the numerator is a float, so maybe that takes precedent for whatever the resulting value will be. Right? We match all the types, and then when we do these conversions, you do need to be explicit about it. So this is a function that takes, I guess, is this a comp time function? I don't actually know how that works, but it seems like it converts it, because there are many different floating point numbers and many different integer numbers. And my guess is there's some way that, like, through this plus the type that you want, you like get a specific version of that function at runtime, or like in your compiled target. But there's some interpretation going on for how that happens. Okay, cool. So, right, we made our image file. Cool. So we have this now, our first ppm image. Yep. It looks like this. And
the one thing, like, I wonder if we should, it's already getting a little cumbersome, like switching, deleting, figuring out how the build steps work. But maybe that's too much. Maybe that's for some other time. There's like a bunch of stuff in a book, you know, like creating the image using some makefile, cmake file. But it's probably not that interesting at this point, at least to me.
Yeah, so it looks like what's happening here is they compile, then they run their program, and they pipe it to an image.ppm.
Right.
And that's what we're doing with Zig build plus the pipe. Yeah. So I think Zig is sort of taking care of some of this stuff for us.
How would you, is there any way to kind of force overwrite of the kind of output to a file so that you don't have to remove it manually all the time?
I don't know.
Or maybe it's like a build. Okay, that's what it is. That's not it.
Try this. Zig, build, run. It looks like it's a...
But it would be weird. Like, that's the piping.
It worked.
It worked?
Yeah.
Oh, okay. Yeah, my other idea would be you could just, in a build step, remove the file.
Right.
Like, clear, like...
I see. But it is kind of nice to just have Zig, build, run, right? Like...
Without this. Yeah.
I was just saying, like, it's nice that the build step is just like like Zig has this all sort of built in, versus with cmake we would maybe need like a bash script or something like that.
Yeah.
Versus this, I mean, maybe what we can do. Oops, how do you? Forgetting my key commands.
Well, that's Z.
So Z is, if I want to read me in here, we could say like sh Zig build run with the image.ppm, and I'll actually also put the git ignore, also add image.ppm. Okay, cool. And I can add run commands and okay.
You know, I started to write these like commit lint messages. Is it?
Yeah.
Call it? And I had a really hard time figuring out like what is a chore and what is a refactor and what is a. Since like you have a lot of these descriptions, like you can use like feature, a feat and fix, and then there are these others, but nobody really talks about like what are these different. You see, like. Of course, I know what is a fix, I know what is a feat, but then the difference is between like the refactor. I guess that's the thing. Like I would mostly just use refactor everywhere because
Yeah.
I'm always refactoring and rewriting things.
I find like I use chore like all the time.
Yeah.
CI I've started using. I used to use chore all. CI it's just anytime I touch like
GitHub
workflows. Now I'm using that. Docs if I have like dedicated docs or even like a README, like I might use docs.
I see, that makes sense.
Style I don't even know what that is. Test.
Right. Style I wouldn't also be able to say. Like, is it maybe for linting or?
Right. And like perf could also be a refactor, right? You like.
Oh, true.
Right.
Yeah,
so
yeah,
there
exactly.
is all this like I at one point I had like there was a CLI that I used. I don't think it's on this computer. No, that's not it. But it was like a tool that like it would prompt you through writing the commit. So you'd say like CCC and then let me see if I can find it npm CCC CLI. Conventional commits. I don't think this is it. Maybe it's this one. Anyway, there was like a little tool that like it would say like what is the scope, what is the and like it would list them, and at least I could remember like, oh, these are my options that I have because I only knew like 3 or 4 of them or something like that. Yeah. I wonder if this is it. I could try it. npm add commit lint CLI. Wonder if it's CCC. No.
Maybe was it
oh no.
an alias for you?
No, I thought it was tmx. Let's see. What is the? I mean this. Oh, this is just a linter. Anyway, I'll look for it sometime. But it was kind of nice because you just have this like, like it at least walked me through like here are your options right now. But
yeah, but it's a sidetrack.
Yeah.
I was trying to see if there's a way to somehow just add a one line in a zig build, build.zig.
Oh, to do that.
Delete the file image, but I feel like I would have to get like acquainted it with this syntax and how it works.
Yeah. For
a little longer.
So we got like 15-ish, 20 minutes left, I think. Yeah.
Yeah, sure.
18 minutes. So we can, let's, on our slight side quest, we can get back. And I think, so we now are able to produce this thing.
Progress indicator, I guess we don't really need that.
I think we can do it though, because it's good. So clog is like, how do you print stuff to like stderr? So if we go to up here, I think I commented out, this.
Okay.
So we already have, I kept this from last time, but we want to print out something. So when you use a pipe, like we could print out like progress messages also to standard out. But what would happen is then if you pipe that, it's going to intermix like this logging code with our actual image format. And so stderr, I think that's what standard debug goes out to. Or what that'll do is it'll print to a separate thread. So that's also why even though we got an error with the bug, we still were like running the program, and some text would still show up in the terminal, but other text went into the file.
Right.
So what you run in standard debug will actually let you.
Okay.
So I think. So yeah, this is a shortcut to using std.io get standard error. So here we're doing get standard out, get writer.
Yeah.
This looks like we can just run std debug itself like this, and we don't need to get this file handle or anything like that. So
because there's only one thing.
Yeah. Versus here we needed to get this standard out file, create this buffered reader. Like it looks like this is a convenience that lets us just print to standard out. So or standard error. So let's grab.
It just essentially runs on an outer loop.
Yeah. So I wonder if we do. I don't know what. Do you know what an R caret is? Like,
what is that?
This right here is this \R. What that means? Let's see.
Is it?
Scan. Oh, I think it's a reset carriage. So what it does is it will.
That's what I was gonna ask.
So that you can like have this progress almost. Yeah.
Like it rewrites, so it's not that you would.
Yes.
Kind of the lines would just appear.
Right.
Sequentially. Interesting.
All right. We can do D, and then the thing that we want in here is image. What is it? Image height -1.
Scan lines remaining. Oh, okay. I thought. But then you have to
-J.
have to use the I somewhere.
Here. It's the
yeah.
I think the J.
Yeah. Okay. Good.
And then
there's just a done.
A done. Okay. So they do use flush, so I'm wondering if we need to, but I'll just try it without it first. We did it here at the bottom. Okay. Zig, build, done.
Does it work?
I don't know. Let's see if I.
Oh, it doesn't look like it works because it. Oh.
Well, I think I need to do zig, build, run, image.ppm. Okay, it did. It just did it really fast. See, we have done. So,
okay.
So it did work.
Maybe you can.
Can we do like a sleep? Is there like a?
Well, it's okay. I think. Oh. Yeah, that's true. No, I was thinking like you can just blow it up really a lot. You can make a image which is like I don't know 1000 by 10,000 by 10,000.
Did that time.sleep.
Okay. That's fine.
So
Yeah,
we can
standard
try that.
library.
I think that time. We can try like 100.
Is it in milliseconds?
Let's just try it.
Microseconds. Not enough. Sleep more. Okay, I think you have to. Maybe you need to flush the debug at every time. Wait. There is nothing. It just says here.
Oh, I think. Whoa, it's nanoseconds. So I think we might need to times it. So if we wanted it, so like times 1,000, we can do times 1,000. So I think let's just try. This should be 1 second. I think. No, it still seemed kind of fast.
Well, it was also printing the standard output. Oh, I see. Okay.
Okay, it is working.
There is something.
So
cool.
There we go.
You can like. Oh yeah, like every time you can. This is what I wanted. You can do this so that it's not on the same line as the kind of other output.
Where? Sorry.
I just added like the next line.
Okay.
The scan line remaining.
I'll cancel this.
Yeah.
We can try to do 100 milliseconds. Yeah, but now we don't get the reset. Really, so I don't. Maybe it could just be that it doesn't play well with like Zig's thing also doing something the same way. But okay, it's working.
Yeah.
And now we have some debugging, I guess. Cool.
Because I guess the thing is, if you're gonna be rendering something that's a normal resolution, doing some rather heavy processing or computation, it can take some time, right? Like
right.
In a Blender, when you're rendering stuff, it can
right.
take.
And especially if we're doing this on the CPU, right? For some of this,
yeah.
like, if it gets to be kind of... Okay, cool. So maybe we can try to jump into this vec thing. So almost all the graphics programs have some classes for storing geometries, okay? Or sorry, geometric vectors and colors. Ah, okay. In many systems. For our purposes, 3 coordinates will suffice. We want to create a class of a vec3 for color, locations, directions, offsets, whatever. So it's like a pretty important primitive in rendering is a vector. Okay. Some people don't like this because it doesn't prevent you from doing silly things like subtracting the position from the color.
Right.
Yeah, I'm guessing in C this is probably the case, but like I think I'm wondering if Zig or like in Rust, for example, like you can actually avoid subtracting like by marking a type.
You can do it.
Yeah.
You can definitely design it as this kind of 3 values together are color and
right.
And it's the same shape, but it's a different type, so you can definitely safeguard for it.
Avoid. Yeah. Okay. Cool.
I guess in practice it's just a little bit. I mean, maybe actually like a more modern or more developed type system can help you out with this, because you just at some point you're gonna want to have a velocity, let's say, for some animation, and then you are adding that to a position, which is like the same 2 like vec3s.
Yeah.
But you can also make them a different type. But then I guess you can make an operator that does exactly that. So not an issue.
Right. Yeah, I think with special. I remember when I was doing some of this in Rust, I already started getting into doing some like almost operator like overloading stuff because I was familiar with it, but I don't know how to. I'm new to learning how to make a type in Zig.
Yeah. So I think this is one thing that I did. I think I found it.
Cool.
In the documentation actually. Like
cool.
I was trying to figure out, because you don't have anything like a class, right? I don't think there is anything like that.
In Zig?
Yeah. So you have a struct.
Mm-hmm.
And I think, this is exactly where I lifted it from. Because a struct can have, if you just look up the documentation, look at the structs, maybe
Here we go.
In the left. Yeah. So you can have a struct that has some, what would you call it? Is it an attribute? No, a field. So a struct that has these fields, and then it can have methods that you call then after, like with this dot.
Yep.
Syntax. And maybe the interesting thing is that you can have there doesn't seem to be difference between. It almost seems that always you can kind of use the first parameter can be the thing calling it. So you have these 2 versions, you see? Like you can call something like with the name of the struct type, dot something, or you could probably call, if it's the same type as the vec, you could call it just like a self is the object that you're calling it on. But you could also write like vec dot
and then pass vec,
and then pass like 2 vecs.
Right.
Or you could just do vec1 dot vec2. That's an interesting kind of thing I observed, and I hope that this is kind of intentional in how it works.
Yeah, so this reminds me actually quite a bit of Rust as well. So in Rust, they sort of get rid of this idea, and it seems like they're doing the same here, of even being able to form like object inheritance. Like you can't do inheritance because you don't have classes, so you can't say like I need this to extend from this class. It's like not something you can do. In Rust, there's something that are called traits, which is how you define shared behavior. So if you want something to like share behavior with something else, you have it implement a trait, which is sort of like a group of methods. But a struct, Rust also calls them structs. So you define like your data, and then you define implementations, which are like methods that operate on top of that data. And it seems like there's almost this like convenience that is like, these aren't anything other than basically just a function, right? But in the case where I'm guessing self is maybe a special keyword here.
I don't think so.
Really? Okay.
I don't think that's anything special. I think,
but then on the instance you can call dot and it passes itself in.
Well, so that's the thing. I think this is the example that shows that you can do the same thing.
Right.
Other than being struct methods are not special, you can reference them. So you can essentially do the same, like do both, and they have the same meaning.
Right. I guess, but in this case, if you call dot init, so maybe you get to run a compilation error because
the type is not
the same. Cool. Yeah. Okay.
I don't know what's the like.
That
balance.
Seems like that's kind of this like Zig like comp time stuff where like it's really flexible to like let you call in a lot of different ways, but then if you're using it a weird way, you'll get like a compile error.
And like the C++, I guess, way would be you make a static method. So then I guess you have a kind of a method that gets you the two vectors and makes the dot product, or you just make another method that is like, this one dot product with another. So you essentially end up with two methods unnecessarily. So this kind of unifies it.
Yeah, it's sort of like this dynamic piece here makes it more ergonomic to use. Like it's just like why make it special? Like if you call a signature with fewer than 2 arguments, then we'll pass in self as like his own type as the first argument. Yeah.
And I guess it's interesting to compare, maybe not, with the C++ from the book, because it has a class vector3 that has a pretty typical structure, and it uses like operator overloading, which
here.
Yeah. And do they have any? Well, let's.
Right. So. Okay, we've got a couple minutes left, so we can. Maybe I will close this sidebar. Okay, so at the top of this file, I'm going to paste in the vec, but then we can. Okay, so this is from the Zig docs.
Yeah, I guess
and we probably want a pub init, this is like your constructor, right?
Yeah.
So,
but again, nothing special, no special keyword.
Right. I would almost call this like so they have overloads, right? So here's saying if you call vec without anything, you get this.
Yeah.
But if you call vec with 3 arguments, you get this. And I'm guessing Zig doesn't have like overloads.
I don't think so. There is no operator overloading.
Yeah. When you see an operator in Zig, you know that this is doing something from this table and nothing else.
Right.
Okay, so it's almost like a philosophical.
Yeah. Just like, and I think like Mitchell, he was mentioning it also, just like you take a look at the code and he has a pretty good idea of what that looks like in assembly. So there is no hidden behavior. It's kind of like the philosophy behind
see.
Zig, I guess.
Okay, so we can call something called empty, and this will return a vec. Return.
Or like empty. Like 0 maybe.
Yeah.
Or like.
Yeah, empty would be weird, yeah. Zeros.
Or origin, that's maybe for a vector class. Yeah.
Okay.
And the keyword is actually pub fn. And then you start, XYZ.
Okay, and we want this to be F32.
Mm-hmm.
Y is F32. Z F32. Okay.
Mm-hmm. And there's, yeah, you can try run it, what kind of error it gives you. Because there's a slightly different syntax.
Return type. Oh, I'm not telling what I'm returning.
I see.
So.
And that's just without any colon. It just states it behind.
Do you no colon? It's just like a
no colon. Yeah, just this.
Oh, okay.
It's kind of interesting.
Yeah. In Rust, it's like you do like a little arrow.
Yeah. Right. Yeah. Yeah.
But it does make you question like why. Okay. Use of vec3.
That's one thing.
Okay, so
that works.
It compiles.
Oh, interesting. Because the thing from here is like this. You have to explicitly bind it to the fields.
I see. Oh, yeah. So I got this syntax from Rust, where it's kind of like what we're familiar with in TypeScript too, where like if the fields match the object, like so if this was like something else, then you'd have to do, I'm guessing, like something else, or maybe we'd even have to do
dot.
Yeah, like we could try this. What was this? Comma.
It seems like weird with the matching, with the highlighting. Do you have a typo maybe?
Oh, else is a keyword. It could be just that you can't have else. I don't know.
That's funky.
Ooh. Can we try that? Same error? What if we move?
Maybe you have to do it like with all. Oh, that would be weird. I would. Okay, my assumption now is that it's not doing like the name similarity. It's just that you either have to like enumerate all the fields and then it's gonna assign them in order.
So if I went like this, I guess that's how we could test, right?
Just do like ABC, like make the parameters ABC.
Okay. All right, so this will be A. Whoops. C, and then we do A. Whoops. A. B and C. Okay, so it's like the ordering. But so I'm guessing maybe the safer thing to do is this syntax, because you want to make sure that the whoops, dot C, and this should work. Yeah. Okay, so I'll rename these X, Y. I guess it doesn't really matter. Let's see. X, Y, Z. Okay, so that's good to know. And then, is there a? I was trying to see if there's a Zig format. Oh, there it is. Zig. Zig format. Can I do source? There, okay. Okay, so this is it for today.
Sure.
Commit, and I'll just say feature start vec3 stuff. Oh, and we'll create a PR. Cool. Well, that was week 2. Yeah, sounds good.
Pretty cool.